Alright, in the last video I tried to explain the designations of R versus S for chiral molecules using our mascot, the chiral doggy, 1-chloroethanol, looks a little like a cute doggy. Again, one of his mitts is green and the other paw is white, so chlorine versus hydrogen. And this one here, if I put the lowest priority group in back, the hydrogen, you can see that chlorine to oxygen to methyl goes clockwise. So this is the R isomer. And one of the things that chemists struggled to do was to come up with some convention of how we were going to draw things on a page so that the chirality would be apparent. So the Fischer projection is the way they decided to do that. And last video I showed wedges and dashes, and the convention is that when you draw a Fischer projection for a chiral molecule, the things on the top and the bottom are the ones that are pointed away from you. So there'll be a chiral carbon in the center, and the ones on the top and the bottom of the page will be away from you, and the ones to the left and the right will be going towards you. And that's something with the tetrahedron, and I really hope that you guys have model sets while you look at these, so you don't have to rely on visualizing my model set. But one good way to visualize the tetrahedron is to have one atom in back, and then three of them pointing towards you in the front. And that way you can see the clockwise, counterclockwise. The other way to vision a tetrahedron is you can look straight down between two atoms. So like here's a hydrogen and the OH. If you look straight down between those two atoms, you got these guys pointing towards you, those guys pointing away from you, and it sort of looks like a T. So T right there. And so if I go ahead and draw this, right, where I have the hydrogen going towards me, the OH going towards me, the chlorine going away from me, and the methyl going away from me, then that would be one way to draw the tetrahedron. Now when they did Fischer projections, they said that this is going to be the orientation of a Fischer projection. So Fischer projection, the chiral carbon goes in the center. Whatever is on top, we know is pointing away from us. Whatever is on the bottom, we know is pointing away from us. Now to reconcile the R versus S designation and the Fischer projection, what is very useful to do, so very useful, is to put the hydrogen in the top or bottom position. And what a lot of people call that is proper perspective, because when the hydrogen is behind, then the other three groups are set right for assigning the chirality. So let me give you an example again. This guy is the R isomer, my left-handed doggy. When I hold him like this, you can see he's R, chlorine, oxygen, carbon. In that order, clockwise. Now if I put the hydrogen in back, right, the hydrogen in back on the top, then that's appropriate for the Fischer projection. So I've got the hydrogen is behind the page, the methyl is behind the page, and they're top and bottom. So here, top and bottom. And now on the left is the chlorine, and on the right is the OH. So this is the perspective drawing with dashes and wedges to show the R isomer. And you can see with the hydrogen in back, the other groups adopt the right configuration, 1, 2, 3, clockwise. Right, so that's the R isomer drawn in proper perspective. And if we drew the Fischer diagram, it's a lot less drawing because we're not going to draw the dashes and wedges in the Fischer projection. What's in front and what's in back is assumed. So there's the R isomer, the Fischer projection. And if you ever need the S isomer, just like in real life, if you draw the mirror image, so I put the OH close to the mirror, put the chiral carbon in the center, put the chlorine away from the mirror, put the hydrogen in the top, methyl in the bottom. This is the mirror image. So if I grab the mirror image mascot, you can hopefully see that with the hydrogen in back, chlorine, oxygen, carbon, counterclockwise. So the hydrogen in back, proper perspective, chlorine, oxygen, carbon, counterclockwise, 1, 2, 3. That's the S isomer drawn in Fischer projection to show the correct chirality. So the Fischer projections are two-dimensional drawings that, because there's assumptions about the three-dimensionality of this, top and bottom things are pointing away from us, left and right things are pointing towards us, that makes it a three-dimensional in our imagination. So there we go. Now, one of the other things I'll spend a minute talking about is sometimes you go ahead and you accidentally put the hydrogen moving towards you, or if somebody else gives you a picture where they put the hydrogen in a position that's towards us, right? So in this case, the hydrogen is towards us, the chlorine is towards us, the CH3 is behind, and the OH is behind. So with the hydrogen in front, this is the opposite of proper perspective, because to assign chirality, you're supposed to have the hydrogen in the back, and now we've got it in the front. So let's see if we get there, which one of these is the right molecule. This is it. So this molecule is what I've got drawn on the page. Let me put it next to it so you can see. Hydrogen and chlorine towards us with the chlorine on the left. Methyl and oxygen away from us with the methyl on the top. So that's this molecule. And with the hydrogen in the front, 1, 2, 3 is counterclockwise, right? So this appears S. That's the way I'll say it, because if you just look at chlorine, oxygen, and carbon on the page, it's going counterclockwise. But this is with the hydrogen in the front. So that's its opposite world. What it looks like is the reverse of what it is. Because it's the opposite of proper perspective, it is the opposite chirality from the way it looks on the page. So now if I reverse this, put the hydrogen in the back, now you can see it's really chlorine, oxygen, carbon, clockwise. So if you ever have a perspective where the hydrogen's in the front, it looks backwards from what it really is. So proper perspective is important in seeing it the way it is. If you're ever looking at it the opposite of proper perspective, you can look at the way it appears counterclockwise, and then you realize that from the other side, it's actually going clockwise. So there's our molecule drawn in a less convenient way, but still the same molecule and still the chirality is assignable. So Fischer projections assume which things are coming towards you and which are away, and I would really encourage you to work with models if you can, but if not, hopefully looking at these molecules, pausing when you need to take a look at the orientation of the molecule and how it compares to the drawing on the page, hopefully it'll get you there.